Hello, everyone. Welcome to this session on building cloud-native data pipelines using Azure Data Factory. And I'm Abhishek. I'm the presenter on this topic, and I work as a program manager in Azure Data Factory team, and I'll be the presenter presenting on this topic. So let's get started. Before we get started, just wanted to quickly run through what Azure Data Factory is. Azure Data Factory is a fully managed serverless data integration service to ingest data and transform all your data, maybe big data, at scale. So in today's topic, let me just move forward with the next slide. We're going to talk about the challenge, and then we will also get into the demos where I will actually show you how to build some data pipelines using Azure Data Factory. And then we'll also see some slightly advanced pipelines and how to go about building those pipelines. And before we get there, we'll talk about some real world challenges and where does Data Factory come into the picture. So typical challenge, as you see in this picture, is while you're ingesting data, and especially in the world of big data, where data is flowing everywhere in social media, in business applications, in databases, and you want to aggregate this data, maybe join, cleanse it to start making sense out of the data. That's a typical challenge that data engineers have today. And the bottleneck it typically happens when you're trying to scale up and consume more and more data, looking into multi-cloud solutions for ingesting data from different places. And these are the typical challenges that customers face, and you get a bottleneck. And Data Factory as a service, as a data ingestion and data transformation service on Azure, not only helps you build a cloud native pipeline. By cloud native, we will get to that, what I mean by cloud native, but it also gives you the scale that you would expect in terms of managing your data, transforming the data, and then putting it into a data warehouse or a data lake, and then consuming that data for analytics purposes. So let's talk about the cloud native ETL benefits, because that's what we're going to talk about in today's topic. And these are probably the key pillars that we want to cover here, starting with ease of use. And it's certainly pretty easy to use. We'll wait for the demos. We'll actually check this out in the demos and how easily you can start building pipelines in Data Factory. It's all UI driven. If you want to write code, you can write that as well. But pretty much it's kind of code-free ETL, ELT. You can also rehost your SSIS packages in case if you have a lot of SSIS packages, and if you want to continue using those SSIS packages onto Azure, but do not want to get into management of the infrastructure, you can let ADF manage those SSIS packages as well. And you can simply rehost those SSIS packages in Azure Data Factory. And we do provide you with built-in Git and a CI/CD system so that you can pretty much at ease make sure that you're constantly developing your code without creating problems for other developers, at the same time able to deliver it into your production, dev test production across those different factories. And then the other pillar is around cost effectiveness, and that's the major reason most of the customers go onto cloud. Is of course there's it's going to be scalable and stuff like that, but at the same time it's more cost effective. You just pay as you use, so it's pay as you go model, which means you don't have to pay upfront for licenses as you would do in other ETL tools. You don't have to pay on a monthly fee or something. You don't have to pay cost per connector. You don't have to pay cost per transform and so on. So it's a pay as you go service. So the amount of consumption that you actually do is what you pay for, and it's fully managed. It's serverless. That's the key part, and it scales on demand. So you get the scale at the right cost over there. And then it's certainly powerful because it gives you 90 plus built-in connectors. It gives you data flows, which is UI-based transformations. You can just simply do drags and drops, and then you can actually get your data transformed, cleansed based on whatever you need out of the data. And it does add intelligence to your ETL system. We do have some autonomous ETL, for example, which can provide you with some insights around the performance. We'll talk about that while you're building data flows, while you're building data movement, data integration in ADF. We do give you AI-based intent, which can help you configure your pipelines in a more efficient manner, in a more performant manner, and that's the whole idea about the intelligence this tool adds onto your data pipelines, making your pipelines more predictive and more cost effective. Now, for those who are slightly new or who haven't used Data Factory before, probably this slide is going to be useful, where typical audience for Data Factory are going to be data engineers, data scientists, citizen integrators. And then on the left-hand side, what you see here is the bunch of data sources that customers have. It could be across cloud. It could be SaaS data services, SaaS data source. It could be on Amazon, Google, or it could be on-prem as well. And so with the rich 90 plus built-in connectors that Data Factory offers, you can get all those data at ease onto Azure. And once you get the data onto Azure, you can start preparing your data, transforming your data, predicting and enriching that data in both code-free manner or code-centric manner. So we'll talk about both. Code-free certainly gives you that ease of use, especially you don't really need to have a code-centric skill set to get started with that. And if you already have a lot of code that you have written in the current environment or on-prem, you can bring that onto ADF and execute those code as well. That's the benefit you get. And then finally comes the serving layer, where you push this data after preparing it, transforming it into the serving layer, where you can serve it via Synapse Pool and then visualize it using Power BI. And the whole process is orchestrated and monitored by Data Factory. So this is where Data Factory comes in. It lets you orchestrate each of these steps of data engineering processes, you might call it as, and then it lets you monitor each of these processes while you build it, and then you monitor it, especially for your operationalized workloads. And then you can have a common data lake, because we see this quite common MDW pattern where you have a data lake as well, where you stage the data and you keep the data for a longer time over there, and then get insights out of it, where you, after preparation, you actually put it into a serving store like data warehouse and then visualize it. Again, breaking that diagram again into slightly more detailed information, where we talk about preparation transformation can be done in different ways. You can use code-free approach, where you can use mapping data flows. That's the proprietary transformation that we introduced in Data Factory. We will talk about that. We'll see this in the demos. And then you have Wrangling data flows as well, especially for people coming from Excel background. You want to do transformation while you're not really you're discovering your data. I may call it as, and Wrangling data flows comes in pretty handy over there. And then if you're code centric and if you're willing to write code, or if you focus on writing code for transforming your data, we do support integrations with other compute environments in Azure, like Databricks, HD Insight, Azure ML, where you can pretty much orchestrate your jobs, write your code, and orchestrate it via ADF. And you can build a much more native experience by kind of using the dynamicity that ADF offers with parameters. You can pass in parameters to your notebooks, to your Spark jobs in Azure ML as well, which kind of builds in kind of a native experience, or near native experience, in terms that you can kind of track lineage and stuff like that. In the sense, you can push in some information from ADF into your Databricks clusters or Databricks jobs, similarly in HDI jobs and Azure ML jobs, and kind of for example, what I typically do is I just add a column with the run ID in Data Factory. So that's a unique ID, which tells me that this particular pipeline initiated this Databricks job or this HD Insight job. And I make sure that in my data sets that are generated via Databricks or HD Insight, I kind of put that marker in one of the columns, which using which I can identify kind of lineage where this data sets came from. from this particular pipeline in Data Factory. So that's also how you can use Data Factory in integrations with other code-centric integrations. And of course, we talked about data ingestion. You can ingest all your data with 90 plus built-in connectors. You can see on the right-hand side, of course, these are not 90. We have more than these, but these are typically the most often used ones. And you can see all these connectors on the right-hand side. And we keep adding connectors. And I'm pretty sure in the next event that you hear me talking, that 90 is going to go to 100 or maybe even higher. And what we see is we pretty much focus with each of these connectors, especially the file-based and binary connectors. We focus on the performance because we know that customers been pulling data not just from Azure, but it comes from different multi-clouds. For example, Amazon S3, or the data might be residing on on-prem file systems, FTPs, and whatnot. And hence, performance is one of the key bars or criteria when we are building these connectors. And so what you can see is we do achieve with a single run, and of course this 5 GB per second, we're talking about a single run, not parallel runs, but a single run, you can achieve 5 gigabytes per second, which is pretty high, but that's what the offering here is. We're talking about cloud scale, we're talking about big data, and hence, of course, you need a big throughput here. And this is a focus that when we build connectors, especially the file and the binary based connectors, that we give you something performance of that kind of range. And of course, there's a lot of performance tuning exercises. The performance depends on a lot of different factors, like your source throttling, the sync throttling, what piece is actually throttling in there. But in terms of the compute, you can bring enormous compute from ADF perspective to kind of power your data movement so that you can get throughputs of the size of 5 GB per second. And that's pretty much what you can achieve on a single storage account. But think of scenarios where if you're migrating large data lakes, you can even multiply this throughput by using practices like using multiple or different accounts, a good partitioning pattern in your data, copying in a binary format. And there are multiple ways you can improve this performance, and even multiply these performance by writing multiple parallel copy jobs in a single data factory. So pretty much you can do real large migrations, data lake migrations with the connectors that we offer over here. And then comes the transformation. So once you land the data on Azure, the next step becomes let's get some sense out of the data, cleanse that data, or transform that data. And this is where the mapping data flows comes in. We talked about the code-centric and the code-free one. Mapping data flows completely code-free. It gives you beautiful visual UI where you can start to write the steps, starting from your source data set to the next step, what you're going to do, which columns you're going to select from your source, and then what kind of transformations you're going to do. In this case, it's lookup, and so on. So you can pretty much define visually the transformations, the cleaning that you want to do, and then based on that, you get the output. And it scales beautifully because at the end of the day, the execution environment that this guy is going to run the code in. Of course, you don't write the code, we generate the code, but that whole code is going to execute on a Spark cluster, which is scalable, which is a distributed compute. So you don't have to worry about the size of data that you have, and that can, typically what happens is when people start doing this, building these pipelines, they have test data sets, which goes into production. Over time, the data set sizes, volume starts to increase. That's a typical big data pattern, and this is where Spark compute comes into picture, where you can easily scale up per job the amount of nodes that you're using. In our case, we call it data integration units, and you can pretty much scale the core counts that Dataflow offers you to kind of meet any demands that you have. So under the hood, it's a distributed compute, so it kind of scales across multiple nodes and processes your data. And one more thing which I would like to add is it's completely managed by Data Factory. So though it sounds so complex when I say it's distributed compute system and all those kind of things, at the end of the day, what the end user does is nothing but focuses on the data flows, focuses on the visual transformations that you had to write, on the business logic that you have to meet, and handling of the cluster creation, running your job on the cluster, handling any exceptions, throwing those information back to the user, monitoring, all those things are completely taken care by ADF. So the cluster creation, the cluster tear down, all those things will be managed by the service itself. So you don't have to literally know ABC and nothing about Spark, yet you can do big data transformations. And that I see as a very, very important value, especially for people who do not have the skill set in terms of specifically in Spark. In they don't know Java. You don't need to know Java. Yet you can actually transform big data. All you need to know is the business logic, understand the business, what you want out of the data, and you can pretty much now achieve that with data flows in a visual manner. So at a higher level, ADF data flows, which we talked about, the visual transformations, this is a high level service architecture. You start with a data flow UI designer, and then in the UI designer, you actually specify what kind of transformations you want. And once you have defined the transformations that you want in the backend, we do generate some data flow scripts. We call it DSL, and this is the proprietary scripts that we generate out of the UI designer. And you don't have to worry about it. But if you want to learn the script, you can always refer to our documentation, understand what the script looks like, how it works. You can even modify these scripts if you wish to. And then finally, there's a in the execution environment on the clusters, we kind of run those scripts up. And then once the job is executed, you will find the details all in the monitoring view. And we will get to the demos and we'll talk about those more in detail. And we also talked about the wrangling data flows. This is yet another option that you have with data flows. One is the mapping data flows, more suited for data engineers who know where, in what format they want to land the data in, and what are the transformations they want to run in. But in case if you are kind of exploring your data, finding more insights out of it while on the fly, and then wrangling data flow can come in very handy over there. And this is something, especially people coming from the Excel background, the business analysts who come from that Excel background with the Power Pivot, they would kind of love the experience that you get in wrangling data flows. As you can see in the UI, it's pretty much the same. And again, it runs under the hood on Spark, so it can really scale out to an extent which your Excels cannot do. So that's the advantage over here. Now we'll quickly also touch upon the code-free. We did talk about the code-free one. Now we'll quickly talk about the code-centric approach as well, where customers do want to write code because they either have existing piece of code or they have the skill set where they would want to write Databricks notebooks in Scala or Python, or they already have it and they want to just execute against these environments. So we do support all the Azure big data computes. You can see Databricks, HD Insight. Of course, you can run stored procedures and Synapse pools as well. And then there's machine learning integration, ADX Data Explorer. There's Azure Functions. Not really used for big data, but you can think of it as if there's any serverless compute required in your transformation process, which can be kind of done in a lightweight manner on Azure Functions, which is a serverless compute, you can use that integration as well. Many customers use that for control flow extensibility as well. For example, extending some functionalities in the control flow while you're building these data pipelines, you can pretty much do on Azure Functions and integrate that natively in ADF. And then if you have some heavy code that you're running, which requires GPU, intensive memory, you can use Azure Batch as well. And we have a custom activity where you can run your custom executables that you have written over time on a highly scalable Azure Batch. We did touch upon monitoring. That's one of the key things once you author the pipeline. The next step is you want to run those pipelines and monitor those pipelines and understand point of failures, start to debug them, and And of course, that's one of the key things. So in terms of monitoring, we do integrate with other Azure services, which focuses on monitoring. For example, Azure Monitor is one of the monitoring services used by most of services on Azure. And it's also something which customers want to use along with log analytics, where you can run queries on those logs. And we integrate with both of them, and we push these logs that gets generated in Data Factory. You can of course use Data Factory UI to kind of look into those logs, but you can also push these logs into Azure Monitor and set certain alerts. For example, if a pipeline fails, you can get alerted automatically. Or let's say you can push it into log analytics, where you can build dashboards, and not just from a single factory, but from multiple factories. Think of large organizations with certain SREs who kind of manage whole set of data factories, maybe more than 100 data factories. It's going to be cumbersome if you have to log into each one of those data factories and then monitor those pipelines. So a better approach would be to use systems like log analytics and push all the data from each factory into log analytics. That's a one-time thing. And once you do it, that plumbing, you can always query things in log analytics, build a dashboard in log analytics, which kind of adds data from all the different factories. So it's very easy to kind of monitor in that particular approach. And we did talk about identifying the bottlenecks and some kind of intelligence that, of course, Data Factory adds while you're building your data integration pipelines. In case of copy, you can see it'll kind of show up performance tuning tips on the top, as you can see here, which is a very good cue, especially as a new ETL developer, or even as an advanced ETL developer. Based on the data sets that you're working with, things can change. For example, the same pipeline used to run exceptionally well, and then all of a sudden, after there was a spike in sales due to enormous sales during the holiday season, your pipeline starts to kind of give you a slightly bad performance. And this is where you can go into the monitoring view, and it can start to tell you more meaningful information about what could be going wrong. And this information is not just kind of a static information. It comes from after analyzing the actual source in the sink, and the various kind of logs that we can analyze for your particular run. And we can give you more meaningful messages. Say there are some throttling happening either on a source side or on a sink side. In this case, you can see there's kind of a write operation which was throttled on the sink. It could be that you're trying to write a lot of data or a lot of small files at the same time, or maybe it's not well partitioned, and so it's kind of hitting under the same partition on storage account, which is kind of causing this throttling. So it gives you this meaningful information which can tell you that even if I now at this point in time increase the DIU or concurrent connections, it's not going to improve performance, because the throttling is happening on my sink side. My storage account is not able to take up this kind of load that Data Factory is trying to push on it. So you can go back, of course, to your storage account and see if there's any improvement in terms of partitioning that we can do, what exact issue that the storage is throttling for. You can find more details about there, and we'll point you to the right documentations through the monitoring message. Similarly, for data flows where you're actually writing transformations for transforming the data, the challenge becomes, like, copy was quite simple because you had a source and a sink. So it's always between a source and a sink and no transformation in between. Yet we gave those important suggestions in terms of improving your performance. Now, in case of data flows, the challenge is much more complex and convoluted. So you can see that you can have multiple data sets in a single data flow, and you can have different sync for those data sets. You can be doing multiple joins in between, and hence it's very, very important to understand different aspects which are those steps which is taking more than longer. For example, you can see there's a cluster startup time. Many customers actually do not see this and feel that data flow is taking a lot of time. But under the hood, as we said earlier, we're going to create a Spark cluster because we have to make sure we meet the big data scale, right, in terms of consuming the big data, which means we need to have distributed compute. And of course, after getting the data onto Azure and then running all those transformations, in a more real world scenario, you would want to do some kind of complex orchestration. What I mean by that is you might want to do some conditionals, if this, then that kind of thing. And typically in data engineering pipelines, you want to kind of chain instructions. For example, I want to run this copy job only when this brings in the data onto the cloud, then I want to do the transformations of the data. There's no point in running both in parallel, and hence you might want to kind of chain them in an order so that it runs sequentially. You can do multiple copy jobs in parallel as well, because each of them are independent jobs, and you can pretty much do those independent executions as well. So you need an orchestration which can scale your orchestration to your big data scale requirements. In this case, you can see you can have multiple activities. You can chain the activities on failure, on success. All those conditions can be used. You have iterators like for each, where you can iterate through a metadata file. For example, if you have list of tables that you want to copy data from, you can basically query, or you can have a metadata file which can give you the list of, for example, table names, and you can parameterize these table names and use a for each iteration. And each for each could probably do that copy execution, and each copy job will actually copy data from a single table, right? And each of these items that you will kind of feed in through the for each iterator into the activity will be parameterized at each activity level. So you can pretty much do such dynamic pipelines in Data Factory, and you can use the beautiful orchestration systems here, which can basically talk to self-hosted integration runtime. We didn't touch upon that, but typically the execution environment that ADF uses, we term that as integration runtime. And we have typically two kinds of those integration runtimes. One is a self-hosted one, which can be set up by customers either on-premise or on different cloud. And then there's managed version of that integration runtime, and we call that as Azure Integration Runtime. It can scale out, scale up any moment. You don't have to worry about it at all. It's completely managed by Data Factory as a service. Now, I'm going to quickly talk about some of the scenarios, and one of the scenarios were around SSIS. We talked about that earlier, and it's a very easy process to kind of get your existing SSIS workloads onto Azure Data Factory, and you can completely get rid of managing the infrastructure on-prem, and you can completely move to the cloud. So this is a very strong proposal for customers who are looking to move on to the cloud, migrate to the cloud for cost savings, for ease of use, all those, or even modernize their existing SSIS-based solutions to kind of target big data in the future. You can basically bring SSIS packages onto Azure Data Factory, and here's the first step where you get the package as is into ADF with no code changes. The same package as is, as I say, it's as is, no code changes. You can get into ADF, and then slowly you can start to modify it to kind of target big data scale using data flows as an intermediate step in between. And you can start always with rehosting an SSIS package successfully onto ADF, and the steps are pretty simple. It's the same package, and you don't have to really touch the package or edit the package, and everything will work. We have tutorials online. You can actually reference one of those tutorials and then make this whole scenario work in ADF. And this is what I was referring to, enhancing your ETL packages with Data Factories. You can still bring in your existing work that you have done on SSIS onto Azure, and then you can start to kind of use additional activities and the same orchestrator that Data Factory offers you to build kind of these native capabilities like the web activities, the copy activities, the data flow activities. You can similarly bring in SSIS packages and run it as an SSIS activity in Data Factory with all the control flow. All the control flow works the same way as it works with any other activity in Data Factory. I think with this, let's dive into the demos. So I have a Data Factory. You can very quickly create a Data Factory. It just takes a few seconds and clicks. Go on to portal.azure.com, click on search for Data Factory over here. And then you can simply go ahead, create a new data factory. And it just takes a few clicks. As I said, put in resource group, region, version 2. Don't select version 1, select version 2. That's the latest data factory version. You can select the region. We have a bunch of regions where it's supported. So and give it a name, and then click on next, and it'll quickly create a new data factory instance. I already have a data factory instance created over here, and I'm going to use this. So this is once you log into Data Factory, once you have created that, you can either log in through the Azure portal, or you can log in into adf.azure.com and select the right subscriptions and stuff, and then log in into your Data Factory instance. Now, on the left-hand side, you can start to see there's a home, which basically kind of brings in into your overview page of this data factory. And then you can start to author your pipelines by clicking on this author tab. More importantly, what you can do is when you have a new data factory, you can also bind, like you set up a code repository. And this is what I want to talk about, especially when you're working in a dev environment with multiple developers. It might be a good idea to have CI/CD enabled, a Git repo kind of bound to the data factory instance. And you can do that from here. You can click on this button. You can start to bind either Azure DevOps or GitHub. These are the two Git repos that we support. And it's a very simple process. Click on this and sign in, and then select the particular repo that you have, or you can create one as well, a new one as well. And once you have done that, all the code that you do, you can basically have your own branch, and you can keep checking in on the code, and then there can be a lead in your organization who would make sure that they, once there's a PR, he or she approves that particular PR, and then things gets published. So you can basically follow the same fundamentals, the CI/CD practice that you have once you bind this whole CI/CD integration into that factory. Now, I'm going to move into the author tab, as I said. And I have a few pipelines. We're going to see some, you will see different sections with pipelines, data sets, data flows. I'm going to cover that quickly. You start with a logical pipeline, which basically consists of a few instructions or different kind of activities in it. And that's what pipeline means. And then you create different activities within that pipelines. As you can see, there are multiple activities within the same pipeline. And then each activity, based on the type of that activity, would refer to a data set. What data set means is basically, it's kind of a pointer to your data. For example, it could be a file, it could be a table, it could be anything. Those are data sets. So for example, your data flows, your copy jobs, all of them would require some other kind of data sets to kind of work on it. Now, I also talked about in my scenario, in my demo scenario, what I'm going to do here is I'm going to pull the data from on-prem and transform that data. I'm going to clean up. I have a products table, for example, and it's in CSV format. It contains certain product information, and I got to transform that particular thing, and then finally land that into a data lake storage and into a data warehouse as well, and then finally send an email notification saying I have finished working on this particular slice. So that's the work that I'm going to do right now. I'm just going to quickly start the data flow debug cluster. This is primarily meant when you're using data flows. We talked about the visual transformation layer. When you're using that, you do want to turn on this data flow debug so that the cluster is kind of warm before you get into writing your transformations, validating your transformations over here. And so I just enable that. It's going to take a minute or two to get it ready. But before that, in this particular pipeline, what I do is I start validating my data. And this is basically a process which some customers want to use, especially when your data is coming from a different source or different partner or different teams, and you want to make sure the data is available before you start your whole ETL process. So I'm going to do that. I'm going to checking on that particular files, if they are there or not. If they're not there, I'm going to just go wait for those files, and you can pretty much specify that in the validation activity. By the way, here's the bunch of activities that you can already see. You can move and transform the data using copy and data flow. There's function activity for transformations in case if you need. There's Databricks integration here. Similarly, the data lake, in case if you're using that HD Insight integration with different kinds of supported cluster types that HD Insight supports. And then there are control flow activities. For example, we talked about in case if you want to create a more generic pipeline and then use conditionals like for each iterations, switches, and so on based on the metadata. You want to switch between the different flows. You can do that pretty much using the iteration conditions. Um, and we talked about wrangling data flows as well under Power Query over here and machine learning. And so in validation, this is what I was about to show you. There's something called sleep. You can specify size. So it can basically keep a track of file size of a particular size. Only then it kind of succeeds and goes to the next step. So I'm kind of chaining it right there. And then once the file is available in form of this data set over here, you can edit, create a new one, for example, if you wish to, but you can see a bunch of different data sets over here. So this is how you go about creating different data sets. And I already have a data set here for the binary file, so I'm just going to use that. Then here's a copy activity, which once given a signal that the data set is available for you to copy, this is where we start copying. And one thing which I would want to share is this is a file share, or it's a FTP data set, which is a file system data set, which lives on-prem. It's not on the cloud. And to access this particular data, we are using a self-hosted integration runtime. And if you go into the data set, you will see it's kind of in a file system. It's not on the cloud, and it's using an integration runtime, which is a self-hosted integration runtime. So if you look into this, this is basically an on-prem integration runtime that I have set. It's a 2-node integration runtime, which will fetch my files from on-prem environment. It could be on different multi-cloud as well, and it supports auto upgrade and stuff, which basically means it's a one-time setup for me. Once I set this agents up, we call it self-hosted integration runtime, by the way. Once you set this up, it keeps getting auto updated and stuff with all the new features that Data Factory releases, new connectors and new bug fixes. All those kind of things are pretty much taken care over here. So with this, by the way, if you were to create a new integration runtime or a link service, you can do it from this tab. It's called Manage tab. You can go there and you can pretty much create a new integration runtime. It's a pretty simple setup. It's all here. You can see there's an integration runtime. Click on New. You can start. If you're doing a lift and shift of SSIS, you can go with this or use the one on the top. You can see a self-hosted integration runtime. You can even create a linked self-hosted integration runtime. For example, your IT team manages the integration runtime because it requires installation and stuff like that. You can let them do that and then come here and then link that particular machine to your existing data factory using the linked self-hosted integration runtime. It does not require you to install things because we know many customers might not have permissions to do that. And so coming back to the pipelines and to specifically the copy activity over here. Once we get the files, so the purpose was check if the data is ready, available, and then copy it onto Azure, bring it to the data lake in the staging environment. And once the data is there in the staging environment, use data flows, the visual transformation layer. And this is what this step is all about. And I'm going to get into the data flows. It's a very simple data flow, not a really complex one, but it's more importantly, I just wanted to show you the experience here. You can kind of zoom in. This is your source, and you can add more sources if you want to do a join and stuff. But this is your source. Click on it. You can see your source options. For example, you want to you have a folder, you want to list all files. All those properties are configurable right here. You can have a multi-line row as well. If you want to add a particular column name to kind of mark this particular data set for lineage purpose, you can do that here by specifying a new name. You can filter data sets by start or modified time and start time, end time, all those kind of things. You can get into projections, see how does your data look like, what are the different columns. Of course, data flow, you can do something like detect data types will automatically looking into the data types of your big data sets, automatically assign certain values over here, which you can always override. And if especially we talked about big data and your source being partitioned, you can pretty much imagine that Spark under the hood, which is going to run your code here, does support those. So you can actually have partitions as well. How it helps us is to improve performance. In case if your data at source or sink can be partitioned, we can basically think of it as do a multi-threaded read, a multi-node read. So that's where the partition stuff kicks in. Now, more importantly, let's get to looking into the data. So you have the data ready over here, and there's a quick data preview option over here. Clicked on it. What it does now is that it's actually querying your data, looking into the data using the Spark engine, and then it'll get some data set out here so that you can actually have a look and feel into your data. So here we go. You can see this was the data file which we started. First, we waited for it, validated it. Once it was available, we copied it onto the Azure Data Lake. And then once it's there, now we're going to see how the data looks like and then transform it based on our requirements. So we're going to do some calculations here. For example, this is a pretty bland file. And now what we need to do is the sales season, the holiday season is coming up. So let's add some discounts. So this is basically the pricing sheet of the product, and you can see different branded products, Surface Book 2, different models of different laptops coming from different distributors, and with different pricing and stuff. Of course, these are, I guess, in US dollars. So let's consider that these are US dollars. And then these are different columns as well, like which ones have processing, what kind of processor, some values are null and stuff. But now what we need to do is we need to add a new column. Let's call it as a discounted price or something. And this is the next step. You can see you can add a new step by clicking on it. You can select the transformations that you want to add. So in this case, in the computed column, you can see we just created a new column called discounted pricing, and you can use your logic, of course. Here I've used a very basic logic of giving 20% discount, and that's what this thing means. You can open up the expression builder and you can write expressions here to do the calculations on the particular data type you have. But more importantly, you will see some expression elements like cache lookups and stuff, which basically you can have local variables. If you are passing some value into this data flow from your pipeline, say I want to compute at 30% discount, rather than using this static value as 0.8, why I did multiplication by 0.8 to get 80% price, which is basically 20% discount. So I was calculating 20% discount, but you can put this as a variable value, and you can flow this value through your pipeline itself by having variables and stuff, parameters which you can use here locally, and you can have for different products or different data sets, you can have different values, and all those kind of things is what you can do here with. But in this example, it's a simple, I'm doing some rounding off as well, because as you saw, the data didn't look good. It has like 4 or 5 decimal places, which didn't really look like how the data should look like. It does consume a parameter, and I'm just going to give some dummy parameter and refresh this. So now this is the second step where we created a computed column. You can see discount pricing with 20% discount. So it should basically add new column into the data set and do the calculations, purification, like removal of the keep it to 2 decimal points and stuff. Like those are the things that we did in this particular step. And let's check this out. So this is what we created, discount pricing. You can see we cleaned up a bit. We gave discount, and after that we just removed, striked off. We kept it to 2 decimal places, which makes sense because typically when we talk about pricing, we talk about something like 2 decimal places. Beyond that doesn't make sense. So we did that cleanup over here in this particular column. Similarly, going down next step, which is sorting this particular price. we want to sort this price as well. For example, in the previous list, if you see, it might not necessarily be all sorted out. Different prices. You can see it's most expensive here in the middle versus on the top. So probably just to make things more cleaner for consumption, we might want to kind of list down the most expensive on the top, and hence another sort transform that we added over here, which basically works on that incoming stream. You can see which stream it's working on. Here it's computed column, and then based on that, it does descending order of pricing arrangement of data based on that. And if you go to the data preview, click on this refresh button, you will see the results accordingly. While we get this data, the next step is basically getting removing of some null columns and stuff like that, because that was no more further required, because it didn't add any value into the data. So just dropping those here in this select columns transform, and then finally writing it into the sink. So it's a pretty simple transformation. You can see now it's kind of sorted out based on the price, starting from most expensive to least expensive. And then finally dropping a few columns, and you can do the mapping. You can let be auto mapped and then start delete the ones which you don't want. So in this case, you can see we already deleted a few ones, so we kind of reduce the number of columns. In this case, it was 9. In this case, this is now 7. So we kind of remove the last 2 columns over here. And then finally comes the sink, where you can write it to multiple sinks. For example, you want to create one, you can create a new one as well. So just go ahead and add a new sink. The sink could be of any type which we support. So in terms of writing, and you can see we do support things like writing this into cache, which can be used in subsequent steps. So imagine you're writing a very complex, large data flows, and you want to use the output or compare this output with another transformation that you want to do later on. In case of complex transformations, that would be a common case, and you can store this particular data set in a cache as well. So that's what this cache is. And then similarly, there are some inline data sets that we support. You don't have to specifically create a data set for those, like CDM, Common Data Model, Databricks Delta. If you want to kind of use a Delta Lake in Databricks and then ingest those data in Delta form, you can do that. ORC, Snowflake, we do support Snowflake as well. So if you want to write in Snowflake the data that you transform, you can do those right here. Or you can create a more traditional data set as well, which you already support. We saw a bunch of these data sets. You can just go ahead and create these ones as well. You can find different tabs over here. These are all the same data sets that we support. I'm not going to add that, so I'm just going to delete this value. I just wanted to show you that. And then finally, in the sink, you can just go data preview, just click on the refresh button, and finally, this is how you would validate. This is the final data set that you would finally get in your final. Of course, this is not the whole data because we are only getting a few rows in here. But it pretty much gives you a good idea in terms of how your shape of your data would look like in your sink. And as you saw, each of these steps have different properties as we saw, and similarly you can see you can rename these files in case if you're writing them as files, or you want to partition them. Of course, this is not a good thing what I'm doing here, outputting to a single file, but this is for a demo. Typically you might want to use partitioning so that you can bring in multiple nodes into picture, and each one of them would be writing the files in parallel. That'll give you much better performance. But just for the demo, I just kind of dropped it into a single file so that we can easily test and consume that particular file. But in a big data world, please do not use outputting it to a single file. That kills the performance. Now, getting back to the pipeline, which we saw using data flows, I'm just going to do a trigger run here. And in fact, let me do this. Let me just do a debug run. You can see 2 different kinds of runs. Debug run is especially when you're developing this pipeline and you want to quickly test it. I'm going to quickly do a debug run. I have parameterized a few things. As I said earlier, I don't want to do a static mapping of my input files and on my output files and the file names and stuff. I want to make it more dynamic, kind of metadata driven, where we can we can provide these dynamic values while we execute the pipeline, and that's what exactly I'm doing. For example, the emails, the notification emails that I'm going to send, and so on. All those kind of things are dynamically configured during the execution here. Yeah, it should take a few seconds. Should be pretty quick because this is running on debug cluster. The cluster is already live, and you can see each step. You can see a refresh button here. I'm just going to keep pressing it at shorter intervals. You can see dataset availability. It actually found the data, and hence it succeeded. And then it moved on to the next step, which is copying that data. That should happen again. The complexity of the system looks so simple. It's actually using an on-prem agent to first validate that data and then pulling it from a local file share in a very secured environment, and then bringing that data into a very secured data lake on Azure. And then from there, it's doing the data flow transformation. And that's what it's doing right now, this particular step. You can do monitoring. We talked about the monitoring and how rich the monitoring was. I just clicked on that, and you can see each step here. You can see how long it takes. For example, in this case, of course, it's a debug cluster. It was running, so it just took 17 seconds for us to kind of get hold of it and to start the running the piece of code that we generated, the transformations that we want to do here. So you can see it's kind of working, and sooner or later you will see all the number of rows consumed, the time it took, and stuff like that. All the monitoring information once this whole activity is complete. You can see it just had 41 rows, a single file, and it took what 129 milliseconds and 2 seconds and stuff. So you can see that this was pretty quick, and you have the results in front of you. And I'm just going to close monitoring view, and your pipeline is executed, and you can see the status as succeeded. And you can also see your debug run consumption and stuff. We transparently show you how much does it charge, because it's very important to understand, especially when you're running big data pipelines, how much is it going to bill you. So you can pretty much see after each debug runs that you do, or even if you do an operationalized run going into the monitoring, we will show you the DIU, the basically the charges that you would incur for running this kind of a flow. So you can see it's very less. We ran 4 activities, and 2 activities in self-hosted IR as well. And you can see these are quantity of the consumption units that we expose. And typically the cost is going to be very, this is not in dollars, by the way, this is consumption units. For example, we bill you for 1 unit. This is hardly going to be in something like 0.000 cents, something like that, because for 1,000 runs you get billed 0.0 something. You can check that in pricing calculator, by the way. You can put all these values with the quantity information in the pricing calculator and get the value, but I can tell you that it's not going to cost even 0.1 dollars looking at this value. But you can pretty much go to the pricing calculator and then go ahead and put in the value for data flow, for example. Actually click on it, open up the pricing calculator, and select Data Factory. Here you go. And let's use East US, that's fine. And on this one, I'm going to use data flows, and based on the instances that you use, you can actually figure that out. So this is vCore hour, 0.2, approximately 0.2 of a vCore hour is what gets billed, and you can see this pricing. What you see here is basically for 8 vCores. So you can think of it, and this is 730 hours, by the way. So let's talk about 1 hour. It comes to around $2.19. One thing you need to do is divide it by 8, because this is still 8 vCores over here. It's not 1 vCore, and the unit that we are talking in terms of billing. So you divide this $2.19 divided by 8. That's an hourly cost that we are talking about. But in our case, the actual execution happened in a few seconds. So the billing would be for a minute. So that gets divided by 60. So we got to divide this value $2 divided by 60 divided by Yep, divide by 60 and divide by 8. So that's the real value of the bill that you would incur for running this particular data flow. And which doesn't sound that big, but that's how this billing works. This is what we were talking about earlier, being more cost effective and so on. And then you can run the same job. For example, what I did is I built the same pipeline for code-centric approach as well, where I used Databricks notebook and I translated that piece of code into Python notebooks, and it's right here. If I were to open it up in Databricks, this is what it looks like. I parameterized a few things over here and then went ahead and used some Python code in to kind of call Scala, to call PySpark. And then similarly, there's some SQL functions in Python that I used and then loaded this particular data set into memory. They call it data frames, and then selected a few columns, of course, the ones which you knew. So it's more, you got to understand your data a bit more here, because you are specifying what columns you want to pull, which ones you want to select, of course. So it's not that easy unless you know real Spark and you can do the query, and then based on that you can understand your data and then start to write code. Versus in data flows, you can click on a button, get all the different columns and stuff, what types they are and things like that. Here you got to know your data sets slightly better, or maybe at least do some querying and try it out and then start to write your specific code. So that's what I realized the difference was, but you can pretty much do the same thing over here. It took me a little more time. Of course, I'm not really skilled in Spark, but you can do the same thing. I just gave a 70% discount, 30% discount here in this case, and I just did a new data frame where I added a new column called discount pricing. And the results are pretty much the same. Write it back into storage or SQL. Both runs under Spark clusters, so both are performant, but you can do both them. So I just replaced the same pipeline with one notebook versus Dataflows. Dataflow experience debugging is much more native, and anyways, all these pipelines are cloud native. You don't have to worry about it in terms of the cost, in terms of the performance. It works out pretty well. I think that's about it. I will quickly get back to the slides, and we can then quickly talk about a few fundamentals that we went through. Ease of use of Data Factory. It was very easy to stitch pipelines, create new pipelines, work with data flows. It never felt you're really working with big data sets. Even if you had one, it's more UI based, so it's much easy to get started, and then at the same time, much more scalable. And you can quickly get started, of course, even if it's SSIS. Yes, you can just simply lift and shift that SSIS, run it against the SSIS IRs. It's pretty quick in terms of getting started. It's cost effective. We talked about, we kind of approximated the pricing, but you saw that. How much does it cost you to kind of run this kind of pipeline on a Spark cluster? Imagine if you were to run this against a Spark cluster that you had to create, even just the cluster startup time, which is going to be in a few minutes, is going to cost you, because it's multi-node cluster and stuff like that. So it's going to cost more than this particular value. And similarly, you only pay for what you use, and you can run this pipeline once in a day, once in a month, once in a year, or maybe once in every hour, and you only pay for those few seconds or minutes when it actually runs for. It's powerful. You can ingest data on-prem. The scenario we covered here is on-prem data ingestion, and then transforming it at scale using data flows, and then of course orchestrating it using Data Factory or the pipelines thing over there. And we also talked about monitoring and perf optimizations and stuff that you would get while monitoring. And I think that's about it. And from my side, and I hope you had a nice session. Thank you, and have a nice day ahead. Bye-bye.